All right, scholars, this video is still continuing on trig ratios and applying it, but here we're finding missing angle. So if we look at the diagram that we have been utilizing, instead of going down the path of finding missing side from trig ratio, we are now going to be finding a missing angle. So there's a slight variation. These are the trig ratios that we were constructing and also using to find a missing side. We're going to do a variation on the trig ratios right here. These are called inverse trig ratios, or some people call them inverse trig functions. Okay, so as you can see right here, the classic trig ratios that we developed first really has the angle as an input to the function of sine, cosine, and tangent. They're equivalent to these ratios dealing with opposite, adjacent, and hypotenuse. To get into the function and really get that angle, we have to undo the sine function. To do that, we apply inverse functions, okay? Think inverse is just undo functions, okay? It allows us to crack open sine, cosine, and tangent and get to the input, the angle, okay? So that's why angles, or in this case, angle theta, is by itself. We applied the undo button, or the inverse function, and now we can find what that value, that input angle value is. So let's dive into it. The way that you would read these would be inverse sine. So we would say inverse sine here. This would be inverse cosine. Really not too crazy with the names. And this would be inverse tangent. Inverse tangent. So it would go theta, or angle, is equal to inverse sine of opposite over hypotenuse. Same thing. Theta is equal to inverse cosine of adjacent over hypotenuse. Lastly, for tangent, theta is equal to inverse tan, or inverse tangent, of opposite over adjacent. Let's apply these inverse functions to find missing angles. The process is pretty much the same as what we were doing before, but now we're going to use these inverse functions. Step one, we're going to label right triangles. Then we're going to construct construct the trig ratio that applies to our situation, right, from the given information. Then we're going to use the inverse trig functions to solve for that missing angle measurement. So let's dive into it. Taking a look at this example right here, we need to find, the way that you would read this is the measurement of angle Q. M just means measurement, so we're finding what degree, right, measurement degree is going to be for angle Q. Okay, now that we have that clarified, let's label our right triangle. I'm going to look for the hypotenuse. It is this side right here. This is my hypotenuse. What is my opposite and adjacent? Well, it depends on the angle that I'm looking at. Here I'm looking for angle Q, so this angle right here. This would be my theta that I'm looking for, which means if I make a straight line from that angle, I can find my opposite. So this is my opposite. Leaving the third side, the one next to my angle, the adjacent angle. Okay. Normally, from this, we would say, okay, they give me information about the hypotenuse, they gave me information about the adjacent, so I would do cosine. So I would do cosine of angle Q is equal to 3 square root of 2 over 6 square root of 2, right? I'm just filling in the information I have. The square root of 2, just treat it as a number. Okay, so 3 square root of 2 is a number, and we're just going to write it down because it's easier to write the square root of 2 as square root of 2. But we're going to apply the inverse trig function, so these right here. So I'm going to apply inverse cosine. So I'm going to say that the angle Q, I'm going to put a little hat on there to indicate that is an angle, is equal to the inverse of cosine. But I'm just going to use the same thing that I made right here, the ratio I made. So the adjacent, which is square root of 2, as you can see right here, 3 square root of 2, over my hypotenuse, 6 square root of 2. And there we go. I'm going to grab my calculator. Oh, I got to grab my calculator. Make sure, there we go. So right here is my calculator. I need to make sure I'm in the correct mode. So I'm going to click mode. I'm going to go from radian to degrees. Now that I'm in the correct mode, I can then apply the inverse cosine. So you see where the cosine button is? See right above that in blue, it's the inverse cosine. I want to hit the second button first, then hit cosine, then just put my fraction, 3 square root of 2 over 6 square root of 2. And then I'm going to close that parenthesis and press enter. And there we go. The measurement of angle Q is 60 degrees. So you look right here, my angle is 60 degrees. So there we apply the inverse trig ratio. If you feel confident right now, go and try to practice out. If you go to page 12, you can find the quick code right here, 49E. Otherwise, follow along with me. We're going to go a few more examples. We're going to go to the second one right here, where we have to find the measurement of angle R. So here is my angle R. And this right here is what I'm looking at. This is my theta. So I need to figure that out. So let's find my hypotenuse. It is right here. This is my hypotenuse. What is my opposite side? It's opposite to my angle that I'm looking at, angle R. So this is my opposite side, which is 5. That's great. Now I'm going to find the adjacent side right here. Adjacent. It's the side next to the angle. Okay. I'm given the opposite side, 5, and the hypotenuse. I don't care about the adjacent. Which trig ratio deals with opposite and hypotenuse? It is sine right here. But again, I don't want to use this because this is for missing sides. I'm going to use the one that helps me find missing angles. So I'm going to use the inverse sine. So the angle I'm looking for is angle R. That is equal to the inverse of sine. I'm going to do 5 for the opposite and 9 for the hypotenuse. And let's see what it is. Inverse second, sine, make my fraction, 5 over 9. Close that parenthesis, press enter, and it's approximately 33.7 degrees. 33.7 degrees. So this angle is 33.7 degrees. I'm pretty sure that was correct. Yes. There we go. That's another example. Let's take a look at the other two. So here we are. We need to find measurement of H. So I'm going to look at the angle H. That is the angle that I'm looking for. Let's quickly label this triangle. 90 degrees. Find my hypotenuse right here. Hypotenuse. Find the opposite side. Draw the arrow. Boom. Here's the opposite side. Find the adjacent. Here we are. Which one do I care about? Well, I care about the adjacent and the opposite. So I'm using inverse tan. So the angle H is equal to the inverse of tan, where I put the opposite side on top, 4, and then I put the adjacent on the bottom. And there we go. Grab my calculator. Figure out what it's going to be using my calculator. I'm just setting it up right now. Ooh, I can make approximation signs. There we go. So second tan. There we go. Second tan, alpha y equals. Make my fraction, 4 over 6. Close that parenthesis, boom. And what I get is roughly 33.7. It's kind of crazy that it's pretty much the same one that I got last time, just slightly different. So angle H, the measurement of angle H, is 33.7 degrees. Let's do the last one together. What am I looking for? Angle C. This is the angle that I'm looking for. That is my theta. So let's label real quick. 90 degrees. Hypotenuse is right here. Side opposite to the angle that I'm looking for is the opposite, and the side next to is my adjacent. This is my adjacent. I forgot to label my opposite. There we go. What information am I given? The hypotenuse and adjacent. Which one is that? That's cosine, so I'm going to use the inverse cosine to find angle C. So this is equal to the inverse of cosine 3.2 over 7.5. And now I just need to get my calculator to approximate that. So actually I'm going to move it over here. There we go. Inverse cosine, make my fraction, 3.2 over 7.5. Close that parenthesis. Boom, there we go. I am given that the angle C is approximately 6.47 degrees. And you can see right here, this would mean that my angle is 64.7 degrees. Okay, again, if you feel confident, try your skills with 49E. If you don't, come and see one of us, Toll Center and I, and we can help you. Otherwise, I'll see you guys in the next video. Bye.